You ever turn on the TV to notice that flickering grayscale pixels? Well, this is called static, and it's the heart of all randomness. So today, I'm going to take you through 5 ways of generating randomness. But first, what is randomness? Randomness is the essence of picking based on having an equal chance without ever making a button. Like flipping a coin or rolling a dice. For example, say you have the set S, and the set contains R, B, and G. And you wanted to output 4 random pickings from the set. Say you have a machine called Random Picker, and its input is the set, which contains all the possibilities of the random outputs, and it outputs an n amount of items, which is the random pickings from the input of the set. In this case, it is 4. So say, for example, now you activate the machine, and the string it outputs is R, G, B, and R. Looks pretty random, right? But if we log it again, and it's the same, R, G, B, and R, this is not really random. So how do computers generate random numbers? Well, computers actually use something called pseudo-random number generators. And one example of this is called seed randomness. Say you pick a seed, S, and then multiply it by a constant A, and then add another constant B. And say the seed is 4, the A is 3, and B is 8. And then you take something like mod 7, which takes the remainder of the division by 7. Now this is equal to 6. And then now you plug that answer 6 into the next seed, and that is equal to 5. Now you plug 5 into the next one, and that is equal to 2. Now you do it one more time, and it's equal to 0. But is this really random? Well, yes, it is random. If you're dealing with small data sets, then yes, it is very random. But if you're generating with humongous data sets, it can be a little bit more predictable. And the great thing about seed randomness is it only uses the 4 basic arithmetic operations, such as addition, subtraction, multiplication, and division. Before we get on to the next method, there are some downsides of seed randomness. Say seed randomness picks a set 4, 8, 9, and 0 to 4. These two 4s actually contradict, because if you get the same seed as the starting seed, it'll eventually cause a loop. And this here is called the period length, and you can increase the period length by making bigger and bigger and bigger seeds. Now, another really efficient algorithm for generating randomness is called Xorshift, and it's what I use in my computer, the LPU 2.0. Now, what Xorshift uses is a seed, just like seed randomness. And let's say our seed for this one is 44. Now, we transfer that 44 into binary, which is actually the language computers use, which is a big advantage. Now, we're going to use 8 bits, which actually gives a range for the numbers we're generating. It's from 0 all the way to 255. So now we make an identical copy of our starting number. Let's call it A. And then we shift A, let's say 2 bits over to the left, which multiplies it by 4. And then we need to add the extra zeros and chop the ones on the left. And in this case we get 176, which is pretty random. But we're not done. We need to apply a bitwise XOR to each pair of bits. So if you didn't know, if we call our pair of bits A and B, and then our output is our bitwise XOR. So if A is 0 and B is 0, then our output is 0. If A is 0 and B is 1, then our output is 1. And if A is 1 and B is 0, our output is also 1. And if both of them are on, our output is 0. So you can kind of see the pattern. The ones with only one input on are 1. So we apply the rule 0 and 1. There's only one input on, so it returns 1. 0 and 0 both return 0. 1 and 1 is 0. 0 and 1 is also 1, and we keep applying this until the end of the pair of bits. And this number turns out to be 158, which is pretty random from the other ones. Now, Xorshift is said to be much greater or much more efficient than seed randomness. And Xorshift does loop, but it does very, very rarely. Now, besides the arithmetic operations of generating randomness, there also exists randomness in the outside world, such as the air. Now, the stuff we breathe in wiggles around like a dance party, so how do we do it? So I made a little experiment. So what I'm going to do is I'm going to turn the shower on, and I'm going to record at a specific position and see if that water sprinkler is there or not. If the water sprinkler is there, I'm going to record it as a 1. If it isn't, I'm going to record it as a 0. So I'm going to turn the shower on. I'm not going to get wet. I'm not going to see if I can generate the random numbers of the shower. So in the end I got this data, and for each pair of bits, this is if the rainwater was currently sprinkling in a spot I chosen. So if you record this number in decimal, it's equal to 1445. And now you can increase the range or decrease the range by just removing some of the bits. So this is all for today, and I hope you learned something, and see you next time.